So can you, all of you, see my screen and hear me loud and clear? Can I just get a quick yes from everyone?
Yes, sir.
Okay, great. So today we're going to start this first batch of computer science and Python basics. So this would be a very basic course, and we will spend a lot of time in understanding some of the basics, and we will slowly get into the Python programming as well as we progress. Okay. So this would be a weekend live class, Saturdays and Sundays. It would be completely interactive, and we would have 2 hours per class. So total, we are planning to conduct 10 classes, roughly around 20 hours in the class. So what are we planning to do here is we would have more interactive questions. Please keep your mics muted unless if you want to ask something or if you wanted to uh, raise something, please do keep your mics mute all the time. And once you successfully attend all these classes and complete all the exercises, whatever we share it in the classes, you will be provided with a certification. So this course will be split in two parts. The part A is basics of computer science, and part B is focusing on Python basics. Okay. I'll also quickly walk you through the LMS tool, which we have. Basically, if you log into LMS tool and if you go into My Learning section, you'll be able to access the course which you have subscribed to. So moving forward, you will see all the course material, the documents, the videos, everything will be attached to this course which you have subscribed to. Okay. So let me see if there is some issue. Okay. Maybe the other person is having some connectivity issue. Okay, so let's get started. Okay, so let's start with the introductions, maybe quick 30 seconds. So I'm Madan and I work as a CTO, Global Head of Technology for B2B company. And I've done my master's from IIM Bangalore and also master's from NIT Surathkal in computer science. I've worked for various organizations, just to name few like Flipkart Group, Myntra, AirAsia, Sabre, AOL, and Honeywell, and few others. So the reason why I'm sharing this is just to give, if you learn the basics very well, you could grow to different stages in the computer science field, where I'm currently leading hundreds of software engineers, thousands of applications and programs or computers across the globe for multiple organizations. So it's good that we understand the basics and then we get into the deep programming aspects of it. So let's get started with the unit one today, which is the computer basics. Before that, I would love to also hear a quick introduction and just a one-liner sort of a thing, which class you are in or which grade you are in, and then what is that one hobby and why you want to learn computer science. Let's go maybe 30 seconds around the room so that we get to know each other. Shall we start with Banap, Kashyap?
Yes, sir.
Yeah.
Sir, I study in the 10th standard. Sir, I want to learn coding and all that stuff because I'm really interested in space and uh, for means to learn about anything about space, we need coding and all that stuff. That's why I enrolled in these classes.
Great, great. I think that's a great decision. Meenakshi? Seems like Meenakshi is having some issue. Neil, why don't we go with Neil?
Um, I I study in the ninth standard, and I wanted to join this course because I'm interested in a lot of mechanical engineering. And then I realized for conducting those gears, you need to learn to code. So that's why I've been enrolled into this class so that I can learn how to do that.
Great, great. Devdutt, you wanna go next?
Hi, I'm Devdutt in 7th grade. I am interested in coding to make many apps and games.
Absolutely. Excellent. Okay, how about Jayantika? You wanna try next?
I am Jantika and I'm in 6th grade.
Great. Arisha, you wanna go next?
I just joined.
Yeah, we were just going through and just giving a quick introduction. Okay, no worries.
I'm Arisha. I'm in 7th grade.
Okay, great. So let's get started with the basics today. And this is the first unit. So let's understand, first of all, what is a computer, right? So this session, whatever we are doing, this would be more of an interactive session. Let's make it very interactive. So before giving a clear explanation of what a computer could be and understand what it could do for us, let's understand different perspective from this audience. What is a computer according to you? Anyone wants to give a try? Any takers?
Sir, a computer is a machine or a device which will help us in many ways.
You're absolutely right. Any particular help you get from computers? Anything particular you want to point out?
Like in studies, we can search our doubts in the websites of browsers and all.
Absolutely. Very good. Excellent. Anyone else want to give a quick try? One more.
All right. Uh, it helps us process multiple data in matter of minutes, which when it would take us to do like hours or days.
Absolutely. So, just by hearing both the statements, it looks like computer is a kind of a machine or a device that performs something on behalf of us, some calculations, some operations, and it helps us give some information to us so that we can consume that information, right? So computer is like amalgamation or composition of a lot of hardware components, and also it has some software components which we're going to learn in a very short span of time. Today what we see, that's our definition of computer. It has the ability to take some input. Say if you're typing something in Google search engine to search something, you're giving some input, right? So you're giving some input, then the computer processes it, then it gives you some results so that you can consume, you can use that information. So that's one example. There are various examples for a computer use case today. Say, for example, if you wanted to use a calculator to do complex multiplication or some complex subtraction or addition, right? So we use calculators in the computer. So there is always something which you give to the computer, and the computer does something which we call it as processing, and then it gives back the output which we consume, right? So let's see what are the three basic components what we need, right? So the first one is you need a computer for sure, right? If you have to do something with some processing, computer, we said it's a very useful tool. So first of all, you need a computer, and then you also need an input, right? So you need to give some input to the computer so that it can do something, and then it can give you an output. So these are the three basic constructs, right? So it has an input, the computer processes it, and it gives you an output. That's as simple and as high level it could be, right? So let's deep dive into this. What exactly this means? Okay, so can someone think of different types of computers you have recently used? Any takers? Jayantika, you want to go?
Yes, sir.
Yep.
So, different types of computers. We have Windows, Mac,
Mm-hmm.
then Linux.
Mm-hmm. You're absolutely right. Any other flavors? Anyone else want to give another try? What are the different types of computers you have interacted with so far?
Uh, Interacted, I'm not sure, but there is some the workstation computer and then sometimes mainframe computers.
Exactly. So the computer has various flavors to it, right? It's not just one thing, and it has a lot of difference, and we will see what are the different types of computers very soon, right? Is this a computer? A mouse?
Yes.
From the previous definition, what we said, a computer has an input and it gives some output.
Yes, sir, it's a computer.
No, sir, it is not a computer.
Okay. How about mobile?
It is a
Is
Sir,
mobile a
computer.
it's a
computer?
computer.
Okay. How about a TV? Nowadays, there are a lot of smart TVs where you play YouTube, where you see a lot of
Yeah, it
things,
is a
right?
computer. It is a computer.
You're right. Excellent. I'll explain why it is a computer, right? You also have nowadays a lot of microwave where you set how much of uh, time you want to heat your food and all that stuff. Is it a computer?
Yes, sir.
Excellent. It is also a computer. I'll explain why they are all computers, right? Is a printer a computer?
Yes, sir.
Excellent. And similarly, mouse is also a computer. So why all of them are computers? You have not seen a laptop or a desktop, and still all of them are computers, right? Because all of them is doing something for you. So mobile, it has an interface where you can enter, say for example, it has a keyboard where you can enter a number and make a call, and the call is received and the other person talks to you and you can hear, right? So there is an input and there is a processing and there is an output which is coming out, right? So similarly, for the televisions also, you see there is a remote and you interact, you give an input, the TV responds, it processes, and then it gives you output, right? So in some form, it is also a computer. Similarly, microwave. So microwave also you give some input by setting, okay, 30 seconds is the timer I'm setting to heat my food, and the microwave processes something, and after 30 seconds it gives you the heat or hot food to you, right? So it is also a computer. So a printer, you give an input that I want to print this document, and then the printer gives you a printed document. So that is also a computer. And in case of mouse, so you are moving the mouse and you are clicking. So that is the input what you're giving to the mouse. And mouse is giving an output to your desktop or laptop to move the cursor. That's the reason why it is a computer. So the fundamental concept and the functions of a computer exists in all of them. That's the reason we have selected few examples of computers. So computer does not restrict only to the supercomputer or laptops or desktops or servers. So all of them today what we use has some form or the other form of the computation or computers. Okay. So now we said, yeah, there is a lot of computers. Apart from the basic examples, what we have seen, what other things do you think we need computers for? Why do you need, first of all, computers? It can search something. What if you don't have computers? What is the problem with it? Anyone wants to take this question? Any takers? Jayantika, go ahead. You have your hand raised all the time.
We need computers because computers do things faster for us than we usually do. Like we need like microwave is a computer, so we need a microwave because it can heat stuff faster than we can actually heat, and also it does things for us so that we don't have to do it manually.
Excellent. See, computers are machines. They are physical things. First of all, they can do things faster. You are absolutely right. And also, they do jobs which humans get tired doing it, right? Say if you do the same thing for the whole day for say 6 to 8 hours, will you be keep doing continuously for the ninth hour? No, right? You'll get tired, you'll get bored because you need rest and you cannot do it continuously. But computers, without sleeping, without getting to take rest, they can operate continuously. They make our jobs easier, right? So that people can do better things and computer can do all the repetitive, all the things which takes very time and which is like say very complex also in some cases, right? There are a lot of use cases for computers. I'm just giving some of them. So there are a lot of use cases. We use it for entertainment, playing games, watching movies, heating food, and all that stuff. Okay. Any guesses in which fields are computers used? Any particular area apart from the home where we use computers day to day? Where else do you think the computers are used? Let's make it interactive. Maybe this is the right way of Devdutt wants to go ahead. Devdutt, where do you think the computers are used today?
Sir, for communication.
Absolutely. Any particular use case you can think of? Like say we have discussed about communicating between two people by using a smartphone or a mobile phone. That is a use of a computer. What else? What else you could think of? Where else have you seen computers being used? Maybe think of your surroundings. Jantika, you want to try? Your hand is raised, or Devdutt? Go ahead. Anyone?
Sir, for studies.
Absolutely. Yeah. So for communication, for study, Hold on. Okay. Hey, sorry guys, can you hear me still?
Yes, sir.
Yeah, sorry, there was some internet drop. Okay, so yeah, let's go back. Okay, so we were talking about in which fields the computers are being used, right? We were discussing about that, right?
Yes, sir.
Yeah. So any takers, or what are the fields you could think of apart from what we discussed?
Scientific research and all.
Yeah. So if you see, we use computers in homes, in schools, right? So school, they use it for admission purpose, for billing purpose. In hotels, people use it for billing purpose. In malls, if you go to a movie theater, you see people giving you a printed ticket, right? So that is being printed in the computers. If you go in a taxi, you book a taxi, right? So you use a mobile phone like a Uber app or a Ola app, and also the other person has a mobile phone. That's all a computer, right? So technically, if you see, if you look around, it's almost everywhere, right? So that's where we are in today's life. So it is completely imbibed in our life and it's used everywhere. Do you see the importance of computers? Now let's see how the computers have evolved. The computers what we see today has not evolved just overnight, right? So we as humans, how did we evolve? Anyone want to take a guess? How did we evolve as whatever we are today? Going to office, going to school. Were we like this from day one of the evolution?
No, sir.
How were we earlier?
Sir,
We were.
we were nomads.
Exactly. So we evolved over the period of time. So the same way, the computers also evolved in the last few decades. It did not happen just overnight. It's important for us to understand how did the computers start in first place? What is the foundation for today's computers, right? So let's see some of these things. So the first computers, any guesses when it was invented? What was it? It was way too back sometime 3000 BC before Christ. Any guesses what it is? What is the first computers humans have ever invented or used?
No, sir.
Okay. The first computer humans ever invented and used was the abacus. Okay. So this is the first ever computer used in some form. So the Mesopotamians used this device called abacus to do simple mathematical computations like multiplication. So the abacus had two sections, right? So there is a bottom section and there is a top section. So by using the beads, say the bottom section has like four and the top section has two beads. So the bottom section counts 1, 2, 3, 4, and the top section, each bead counts 5. And just by moving the beads, people used to do simple arithmetic like addition and subtraction and also multiplication sort of thing. So this is the first early primitive sort of a computer, which was way too back. And then people have improvised this, and Napier has come up with something called logs and bones. So there used to be a grid in which there used to be 9 logs and bones. So basically, using and pulling these blocks, Napier gave a simple way of solving a multiplication problem, which is very complex at that time for us to solve with a 9-digit number sort of thing, right? So Napier solved this thing, and this was this some improvised version of the abacus what we have. And then Pascal invented sometime in 1642 a mechanical kind of abacus sort of thing, where if you see there are rotatory tacks, and if you rotate the levers and the tracks, basically you would get a simple multiplication, addition, and subtracting machine, right? So this was way too long back. This is how the primitive computers were used, and because if you see by the definition of a computer, you are giving an input, the machine is processing and giving you an output. So anything which does this three operations is treated as a computer for us. And that's how the primitive computers were. And then in 1670s to 1825, further it got evolved. So Leibniz invented a further enhanced version of the mechanical calculator invented by Pascal. And this did a little bit more than what the Pascal's machine did. So this did more complex multiplication and division as well by just moving the knobs and rotating the levers. This was a kind of a calculator, mechanical calculator, which we have invented sometime in 1673, and then we used it for a while before we started inventing other machines. The next big evolution came when we moved on from addition, subtraction, multiplication machines to differential and analytical functional machines. So Charles Babbage has invented analytical and a differential engine which can do complex function and finite machine algorithms, and sort of it could do some function solving by pulling this complex levers, right? So this is not a calculator. This is a mechanical engine. By providing, like, say, 10 to 15 parameters or variables, you can do all these operations, sort of thing. So here is the picture or a photo of Charles Babbage. Do you know what he is known for? Any guesses? What
Sir,
Charles
he
Babbage is?
invented the computer.
Okay, that's good. He actually invented the most complex machine, what we call it as the differential engine or the analytical engine, which we call it as the early complex computer, right? There is another name to him. Any guesses what it is?
Sir, some father of something, no?
Exactly. He is known as the father of computers because he invented the most complex computing machine at his time, and it was a stepping stone for all the computers, all the machines what we have today. Okay. Then further from the learnings from all the machines what we had invented, then we started inventing electrical machines. Till now it was all mechanical, there was no electricity involved in it, right? So starting from 20th century, we started inventing electrical based computers. In 1944, the Mark I was the first electrical based computer, which was constructed in collaboration with IBM. So it could do, say, for example, multiply two 10-digit numbers, which is very easy for today's even mobiles to do it. At that time, this was a very large electrical computer which can do very, very simple multiplication, division sort of thing in few seconds, right? So this machine was an extension of the Charles Babbage's analytical machine, and this was the electrical version of the analytical engine, the mechanical engine what we had. So that's how we had evolved rather than going into a machine. See, abacus, Charles Babbage's machine, all those things were mechanical. You have to go rotate a lever or pull a knob sort of thing, right? If you see all the earlier versions, they were all mechanical. You have to pull a knob, you have to rotate a knob or some log sort of thing. In this version, we have converted the mechanical model into an electrical model so that we could do a lot of computations without a lot of human intervention. Okay. Okay, so in 1945, then we further evolved something more efficient one, where we see the stepping stone for today's modern computers. So John Newman has proposed a concept called there should be a processor, and there should be a program, and there should be a data. So the processor will take the instructions from the program and stores the data back into the storage device or into the storage memory. This was the first concept which was floated, and this is the stepping stone for all the modern day computation, what we have. Okay. Now we have seen all these computers. Now let's see some of the generations of these computers, right? So any guesses what they are? We said we have evolved from mechanical computers to electrical computers so far. So any guesses what they are?
They are parts from mechanical computers.
No, they are part of an electrical computer. Okay. If you see, this looks like a bulb. Don't you think it looks like a bulb? Right? So this is called the vacuum tube. The first electrical computers were built using the vacuum tube. Okay. So the vacuum tubes used to control the operations in the electrical computers. This is how the electrical computers were built in the initial stages. If you see the first generation of computers built from vacuum tubes between 1945 to 1955, they were so huge, like it used to be like 20, 30 tons in high rooms, and it's like you need 4 to 5 people to operate, so many connections and all that stuff. It's because they're all so heavy, built out of all wires and vacuum tubes and all that stuff. So the vacuum tubes, what they used to do is they used to control just the way how the mechanical knobs are controlled. The vacuum tubes are used to control the electrical signals, to turn it off, to turn it on, so that we can do certain computation. We'll get there. But the problem with the electrical computers were they were so huge, took a lot of space, a lot of electricity. They were unreliable. Say even if one component fails or one bulb fuses, then everything goes wrong. And it was like it was not a commercial product because it was more of a research kind of a product, right? So it also required, because of heating of the vacuum bulbs or tubes, basically the whole machine or the electrical computer used to get heated, and you need a cooling of that, and then it can only operate due to certain period, not more than certain period. The earlier electrical computers were called as UNIVAC 1, ENIAC, and all that stuff, EDVAC sort of thing. That's the first generation computers. And then people felt like, you know what? Computers with these sort of electrical vacuum tubes is very difficult. Then we transitioned from electrical to electronics. So we invented something called a transistor. Instead of having such a huge bulb, we invented transistor, which is very small. Now, electrical to electronics transition happened using this transistors. If you see, this is the first stepping stone of the electronics world in the computing world when we invented the transistors. So basically, transistors made the whole computer very small. If you see from large rooms, the computer started fitting in on the desktop. You see on the bottom. Basically, these are the second generation computers which used to work on the transistors. So the transistors are very, very small compared to the vacuum tubes, which used to be very huge, like say 1 feet, 2 feet, each one of them. So in place of one vacuum tube, you can put like say 1,000 transistors. So now you have saved so much of space. So the transistors are required for you to do the computations or processing inside the computer. Okay. So basically that's how we have reduced the size from an electrical computer, which used to fill in like say huge football field, to fit it on a big desktop sort of thing. Okay. So the first electronical computer was like say UNIVAC 1100 or IBM 1620 sort of thing. So these are the guys. The IBM is the first company which did a commercial computer which can be used on a desktop, which is a portable sort of a thing. Okay, how many of you have heard IBM? Do you know what IBM means or stands for? IBM stands for International Business Machines. So they were the first ones who introduced the second generation computers. Okay. Now, what happened? We were using all the transistor based computers. So, but still transistor based computers, if you see, it reduced from room to desk, but still it was pretty big. So you had a lot of transistors. If you see on the rack, which is filled in, it was all filled in with the transistors. And this was still very heavy. You cannot lift. So you need 3 to 4 people to lift it and keep it on a desktop sort of thing. And that's when we have invented the integrated circuits. So integrated circuits reduced the further dimensions of the computational capabilities of a transistor into a small chip, 1-inch chip. So if you see, the whole size of this whole transistor deck got reduced to such a small chip called integrated circuits. In some cases, we also call them as IC or microprocessor or chips, right? So in today's modern computers, you will see a lot of microprocessors or chips like this. So this is the foundational processor which computes a lot of things and tells you what has been computed, right? So this is now well minimized from large space to a very small chips. So now if you see further, we have seen the third generation computers which had all these ICs and all these chips, basically using a small scale integration sort of thing, where we had designed all these chips, built it into these modern computers, something like IBM 360 or Honeywell 6000 sort of a thing, where now you have evolved from mechanical to electrical to electronics to small chips. So this is all kind of transition into the digital world. Okay, but still these computers were pretty big in size compared to the computers what we have today. And then the fourth generation computers came in. Okay, further we have modified, and this is how the computers used to look like when I started my career learning computers. So this was like the monitor. There used to be a CPU. There used to be a floppy disk cabinet and all that stuff, right? So there were a lot of early computers. So these were called as fourth generation computers. So in these computers, we used very large scale circuits, the transistors or lot of transistors in a small space. And by this time, the microprocessors were developed. If you see, there was a display unit, there was a CPU which has the microprocessor, there is an input device and all that stuff. And this is a very, very portable device which was very reliable, powerful in computing needs. This used to do more than addition, subtraction, multiplication sort of thing. This used to do a little bit more, right? With lesser power consumption and lesser cost. So everyone was able to afford this kind of a computer. So for the common man, this was the computer which actually was accessible in early 1990s, between 1975 to 1995 sort of thing. And the fifth generation computers look something like this, right? So you have a nice MacBook, you have a nice Windows, smartphone, laptops, whatnot, all of these things, right? And it's all connected. Everything is connected. Now I'm speaking to you, you are able to hear me. It's all interconnected. So there are so many things happening today. So the fifth generation computers are still evolving. Today we are in the fifth generation where you have desktops, laptops, tablets, smartphones, TVs, whatnot, everything, printers, all these are part of the today's smart generation, which we also call it as fifth generation, which are all interconnected. So fifth generation, today's generation is still evolving. There are a lot of things in fifth generation computers today. There is internet, there is networking, there is movie streaming. You can watch a movie, we can see each other, all that stuff, right? There are smart devices. Microwave is a smart device. Today's televisions are smart device. There are robots. There are cloud where there are a lot of computers in remote locations where you can access. There are artificial intelligence. There are robots which can talk to you. There is client server computers, distributor, parallel, all these things. There are so many buzzwords, right? Don't worry. So this is the today's generation, and this is the state where we are today. Any questions? So this is the first topic in this whole course. So any questions, any clarifications?
No, sir.
Okay.
No doubt,
So
sir.
how is it so far? You guys are enjoying it, liking it?
Yes, sir.
Okay.
Yes,
So
sir.
what have we seen so far? We have seen mechanical generation of computers, right? What were some of the mechanical computers we had?
The abacus.
Absolutely. What else? We had Napier's log and bones, right? We have the Pascal mechanical machine, Leibniz calculator, all that stuff. Then we evolved into electrical machines, which were using vacuum tubes. And then we evolved to electronical based computers, which used transistors. And we eventually came into the digital world starting from 1975, 1980s, that period where we had the computers. And today we are in the digital world of smart or fifth generation. Okay, great.
Yes, sir.
So, okay, so let's see. Let's take some quick questions. Okay.
Okay,
So
sir.
we have seen a lot of things, right? So far,
Yes,
we
sir.
have learned the evolution of computers, what it was, how it evolved. What do you think is the most important thing in this whole journey? How did the computers evolve? What is the most important thing?
Sir, every computer had the thing that like we give the input and it processes it and gives the output.
Excellent. So everything had the common thing. That's where we started the whole journey, right? We defined the computer by saying, hey, look, computer does some processing by taking an input and it gives an your output. You are absolutely right. That's the first thing what the computers does. Also, the computers have become smarter day by day. The earlier versions, if you see, the abacus could only do addition, nothing more than that, maybe, or subtraction. Then we did multiplication. Then we did with division. Then we said, okay, now let's do a kind of a quadratic equation or a differential equation, right? Using the which device? Which device we said we had an analytical engine and all that stuff. Who invented that? Charles
Sir,
Babbage, right? We said the
yes, sir.
analytical, the differential engine, right?
Yes, sir.
Absolutely. Okay, great. So I want others also to speak up. Maybe this is all basic, but it is good to interact, right? So that we just all get to know how and what we are thinking and what we are feeling, right? So please uh, be vocal and participate because it's important as we progress. It will get more interesting and also a little bit more uh, fun. And if you start participating, it would be very nice. Okay.
Okay, sir.
Thank you.
Okay, sir.
Great. So now let's start the next topic. Okay. The next topic we're going to do is the computer components. Okay. What do you think you have seen in the computing or in the computers? What components does it have?
Sir, the CPU,
Excellent. What else?
the keyboard,
Perfect, man. What else?
The
Today's
mouse.
rockstar is Dave, the Tigers. Guys, all the senior guys,
Storage.
you guys speak up. Yep. What kind of storages you guys have come across so far?
RAM and ROM.
Great, great, perfect. Yeah, so there is one more thing. No one has brought it up. Any guesses what it is? We have spoken about input. We have spoken about CPU, storage,
The monitor.
RAM, ROM. Exactly. What is it? What is a monitor? What kind of device is it?
The monitor is an output device.
Excellent. So a computer primarily has four components. So it has a CPU, which does all the computing thing, right? And we also have storages. After doing the computation, it stores all the results or the data into the storage, whether it is in a hard disk or on a RAM or on ROM, right? And there is an input, right? So we give input using the uh, keyboard, right? Mouse, and you get the output in the display monitor. So these are the four high level basic components what we have in a computer. So these are the hardware components in the computer. Now let's start with brief understanding about input. Okay. So the input unit consists of input devices attached to a computer. So they take the input commands or instructions from humans or from other computers, and they give it to the CPU for processing, right? So there are various set of input devices. We have seen keyboard, we have seen mouse, there are scanners with the printers. The earlier ones also had trackpads, and even today we have trackpads. There is a touchpad, there is a joystick, there is a barcode reader, and few others. This just to name few of them. So these are all the input devices used to capture what? Any guesses? What do we use to capture?
The inputs.
Exactly. We capture the inputs, whether it is from a human or from other computers, so that this can translate the human inputs into inputs which computer can understand. Computer does not understand English. Computer does not understand Hindi, right? Computers only understand electrical language in the form of signals, right?
Yes,
So
sir.
if you are speaking, what is happening when I'm speaking in microphone? The voice is the microphone is converting the voice into electrical signals, and then it is giving it to the computer for processing, and the computer is processing, and then it is giving back to other computer, to you, so that you can hear, right? That is what is happening. So all the input devices does one thing. What they do, they capture physical interactions from touch, voice, or visual, anything, into electrical signals. That's the fundamental job of an input device. What is the job or responsibility of an input device?
To convert it into electrical signals.
Exactly, to convert the input from human interactions or other interactions, physical interactions, into computer understandable signals, which is electrical signals, right? All clear?
Yes, sir.
Yes,
Okay.
sir.
Now it's important for us to just understand how does a computer look like, right? Now we said there are four parts. There is the input device, which we have seen, and there is a CPU. Okay. So usually we have seen some of these desktops, right? How many of you have seen this kind of a desktop?
Sir,
Quick.
me.
Great. Who has not seen this? Whoever is not speaking, I'll
We have
assume that they have
everyone
not.
has seen it.
Excellent. Okay. So did ever you guys have seen or opened and saw what is inside this box?
Me, sir.
Oh man, excellent. Okay, great. So inside this, there are a lot of other components. So the first thing is the power supply. So you take a power cord, put it into the plug so that the power can be drawn into the computer. That's the important thing. And there is a motherboard which is in the pink color. which holds all these components together, right? There is a RAM, there is a microprocessor here, right? There is a video card, there is a sound card, there is a hard disk, there is input output controllers, all these things. All these things are held by a motherboard. Okay, so the motherboard holds all different hardware components so that it can form into a CPU. Got it? And all these things is enclosed into a casing thing. Okay. Do you see any other input device here which we have not seen there in the earlier screen? Let's see who guesses it right first time.
The CD DVD.
Excellent. Who is that? Jayantika?
Jantika.
Okay. Excellent. So the CD DVD is also an input device because using this we insert a disk and the disk gives all the information to the computer to do something. Maybe it could be a music disk, it could be a video disk, so that that information is read and given to the monitor to display and play the music or display the video sort of thing. That's what the computer does. Clear?
Yes,
Okay.
sir.
How many of you seen the laptop? So the laptop seems to be very thin and flat, right?
I've
Yes,
seen
sir.
it. It's very common.
Excellent. All of us have seen it, probably, right? So the laptop also has a similar thing. If you see the same components what we had in the desktop is just shrinked into a smaller resizable or smaller real estate. So if you see there is a motherboard, same motherboard what we had in the big laptop. If you see there is a keyboard, there is a monitor, there is a drive, there is a fan, there is a battery, there is a cord, there is a RAM, hard disk, everything, bottom case, everything. The only difference is earlier the desktops were bit bulky, lengthier sort of thing. Now we have squeezed the same thing into a smaller dimension. There is a motherboard which holds all the components together, and there is a CPU, and there is a display, monitor, keyboard, everything. Okay. Now let's do some deep dive into the CPU. Okay. So we have seen CPU has an input, it has an output, and it has storage, and there is a microprocessor. How many of you heard the name microprocessor?
Sir, I heard
Yes,
it.
sir. I've heard it.
Okay. Any guesses what it does?
No,
What is
sir.
a microprocessor? Okay.
Sir, it processes
Sometimes have
some
you
things.
have you have you ever heard? Yeah. Go ahead. Someone was talking and someone was trying to say what it was. Everyone went quiet.
Sir, it processes the input we give.
Excellent. What else? So in our human body, which part of the body processes all the details and acts accordingly, gives other directions or instructions? Which part of our body?
The brain.
Excellent. So in the computer, the microprocessor is the brain of the computer, which does all the processing. Within the CPU sometimes also gets referred to the whole motherboard, everything. Within that, there is a microprocessor, which is the actual central processing unit, which does the computation. So if you give two numbers, the two numbers are added and it is given back to the output device by the microprocessor. Okay, and it has certain subcomponents like arithmetic logic unit, there is a registering array, control unit, and all that stuff. We will see all of them in detail. So there are subcomponents. So the microprocessor inside has few more guys, let's assume, right? If there is an addition which needs to be done, it is given to the ALU unit. Say, for example, if you want to hold anything within the microprocessor, it is held by the fast memory called registers. Okay. And if you want to control the input and output devices, it is all controlled by the control unit. Okay. And the memory is used to hold all the instructions and store the data back in the memory. The memory could be in various forms. We'll see very soon what types of memories we have. Okay. We will see a little bit more into microprocessors here. So basically, you will hear as you grow into a little bit more advanced classes or grades, you'll come across microprocessors. People will talk about instruction sets, bandwidth, clock speed, word length, data types. How many of you have heard of this thing? Or first of all, how many of you seen a microprocessor?
Sir, me.
Oh, great. So you see a microprocessor on the slide?
Yes, sir. When I was a little kid, my father took this thing out of the CPU and showed.
Mm. Excellent. So this is how the microprocessor looks on your slide left bottom. If you see, that's the microprocessor. That's the brain of the computer, right? So we have shrinked from large rooms of vacuum tubes, transistors, everything into a small 1-inch chip. This is the integrated circuit which does all the computation. Within this, there are a lot of sub components like ALU, control set, and all that stuff. So basically, what microprocessors are responsible to do. Okay, let's see some examples. Okay, so the microprocessor, let's say when you want to do something of a simple task like addition. Okay, let's say you want to add two numbers. Okay, so what they do is when you say add, say 2 plus 2. Okay, so what is the value 2 plus 2?
Sir, 4.
Okay, great. But computers, you understood because you understood English language, right? You understood the problem, you understood the question, and you immediately responded. Our brains understand English language, and also our brains can see through eyes. So eyes is kind of a input device which scans and sends it to the brain, and the brain understands the visual picture of 2 plus 2 means 4, right? So that's how we have responded. But with computers, computers cannot understand if you tell 2 plus 2. Tell me what is the answer. Computers only understand what? Just now we discussed. Computers understand only one language.
Electrical signals.
Exactly. Computers only understand electrical signal. Okay. So what should happen, right? So how do you convert electrical this information into electrical signal? Okay. So it's very important that we understand this, right? So basically, what we do here is we go convert this instruction of add into, say, for example, electrical signals. How do we do that? Any guesses? So there are multiple things. There is A, D space 2 space plus space 2. How do you convert them into electrical signals? Can anyone explain it in quick way?
Sir, in the language of computers and all, it's based on 1 and 0, no?
Yes, absolutely, you are right. You're bang on spot. So basically, this thing needs to be converted into electrical signals. Okay, so electrical signals you can only, how do you tell electricity to do this operation? So what we have done is, say for example, if we can convey, if a signal is on and off. Okay, how do you tell whether if there is a bulb which is glowing and it's on or not? How do you tell? You have bulb in the home, right? Tube light and a lot of bulbs. How do
Yes,
you know
sir.
if the bulb is glowing?
Sir, if it if it produces light around the room and all,
Yeah.
we can tell that
What do you
it's
need to
on.
flow the bulb?
Sir?
You need current, right? You need current to glow to lit the bulb, right?
Yes, sir.
What if the current is not there? The bulb will not flow.
Yes.
Okay, that's the two states. So what happens here is in computers world, so when there is a current, okay, that means there is a signal, right? So current is something like, say for example, imagine like a pipe. Okay, let's assume this is a long pipe. Okay, let's assume this is a long pipe. Okay, something like this. Okay, let's say if you pass water, okay, the water will come on the other side. If you leave a gap, what will happen? There will be space, right? Air. Then you can leave space and again space, again some water. So how will the water come outside on the other side?
Sir, with some duration from after each thing drops.
Yeah. So the water will come, if the water has not been filled continuously, it will come like, say in pockets, right? There will be a lot of break. Okay. Similarly, in current also you can do the same thing. If there is a wire, okay, let's assume there is a wire. You can turn on current, you can pass electrons or current, okay, by using a switch, right? If you turn the switch on, the bulb will glow, right? That's when the current flows. Okay, you control it using a switch, right? So you have a flow of current from the mains into your home. If you use the switch, okay, to a bulb, right? So the bulb glows. If you turn off the switch, what happens?
The bulb stops to glow.
Exactly. Similar way, we use current to control these signals. Okay. So when we say 1, okay, that means the signal is on in the current. When we say 0, that means there is no signal in the wire or in the pipe. That's as simple. Is it clear? The analogy what I'm trying to convey here? This is the most interesting and most important thing. So let's get clarity on this. All of us are clear?
Yes, sir.
Perfect. Okay, so using this, what happens in computers is basically we take, say for example, let's take this example. Let's do one thing. Let's take a simple document so that we can do this. Okay. So let's say now I want to do this simple operation. Add 2 plus 2. Now the problem here is, how do we tell computer? Okay. So what we have done here is, now we have created an instruction set for all of them. Let's say there is a character which says A, B, C and D. Okay, so we have assigned a numeric code, say for example, say 1 to this. Okay, for B 2, okay, for C 3, for D let's say 4, and say similarly, say for example 1 2 3, so let's say we give some gap and say 4. And similarly for special characters like say plus, we would have given some mapping and all that stuff. Okay, so now let's say 1, we have assigned another numerical number, let's say 28, something like this, 29 and so on, and for plus maybe like say 50 and so on. Now the first step is we have converted the character into numbers, and then the numbers is converted into ones and zeros. Okay, that is done using the what number format? Any guesses? You can represent numbers easily in another format. What is that format?
Not sure, sir.
Any guesses from senior folks? Okay, so there is a binary number format which can be used to represent. Say, for example, if we use a number, binary number system, okay, let's say we use a 4-digit, okay, 4-digit number system, okay. Let's say, what does 4-digit number system means? You can put 4 numbers into it, 1 1 1 1. This is a 4-number system, okay, binary system. Okay, let's say for 1 we have used something like this in the binary system. So this is all in the form of 0 0 1s, right? You see so far with me, guys?
Yes, sir. So every like add and all. So the letter A will have a pattern like 1001 like that.
Exactly. When you say something like add 2 plus 2, first it gets converted into something like this. Okay, this is not the exact one. I'm just typing it for reference. Okay, for plus. Okay, okay, like this. This is the input. Now this gets converted into electrical signals easily. One means on. So there are a lot of switches in the computer which turns on and off continuously. That is the transistor. That's all. Got it?
Yes, sir.
Okay. Okay. So now, if you see, this is how we turn these things into computer understandable language, computer understandable electrical signals or pulses. Now, if you see, there are a lot of things what we can hear. Say, for example, we say word length. Okay, this is the word length what we are talking. So we are representing each character by 4 digit. Today's computers takes it to a 64-bit. That's what sometimes you might hear 32-bit, 64-bit. That's the word length of the processing capacity. What so each word is represented by 64 bits. So this is 1 bit, right? 2 bit, 3 bit, okay, 4th bit, 5th bit, 6th bit, 7th bit, 8th bit, 9th bit, 10th bit, 11th bit, 12th bit, 13th bit, 14th bit, 15th bit, 16th bit. If you have 16 bits for each of the addressable word, how big is your computer? What kind of computer it is now? It is a 16-bit computer. Okay, you guys see what I'm saying? If you represent each of the character or word, what we call it here, with say 16-bit, it is called as a 16-bit computer. Any guesses what could be a 32-bit computer? Guys?
So a 32-bit computer.
Yeah. Say when you
Sir,
represent.
this order is repeated twice.
Exactly. If you repeat this twice, okay, if you represent a word or a character, okay, in say 32 bits. See, in this case, if you want to represent only one, all of them will be zeros like this. It's just waste of things. But there are a lot of use cases where you may need such a large width of word byte where you can use the character encoding. Okay, so some of these things might be very confusing, but just I'm giving you some examples. Okay, so that's how you hear called 32-bit, 64-bit sort of computers. Got it? Okay.
Yes, sir.
And if you see, you also might hear a lot of data types, right? So here, how many data types have you seen here? There is a number, right? See, for this input to be processed, there is a number and there is an English word, right? And also there is some special plus operator, right?
The processing sign.
Yes. So if you see, there are different data types which the computer needs to handle. It is not always just addition or just adding two numbers, right? So there are different data types, like say, for example, you will have addition data types, you will have simple integers, numbers, strings, and all that stuff. Okay, that's what you will hear as we move forward. And the clock speed is basically how fast this processor can execute. Let's say this is only one. What if you have 10 instructions like this? How do you tell how fast your computer can execute this? How do you tell? Okay, that is measured by the clock speed of the processor. Okay, if your computer microprocessor can do 2 instructions per second, we can call that as 2 instructions per second. My computer's speed is how much? 2 instructions per second. Let's assume like that to keep it very simple. So today's computers are very, very fast. It can execute millions of instructions like this in a second. Okay, and they operate at a clock frequency, saying I operate like say 2.3 gigahertz, 4 gigahertz. You might have heard of some of these microprocessor terminologies, right? So, or you will hear very soon. Okay, and every microprocessor comes with a predefined instruction set. Say for example, to send this command like this, how would you understand what you're sending is add? The other person, how, say if you send this thing to a microprocessor, how do you know that this is A, this is B, this is C, this is D? Say for example, let's play a game. Okay, let's play a secret agency game. If I send this to you, how do you interpret what this meaning is? Let's say we both are some secret service agencies agents, and we both want to exchange in this format. How do you know what is this mean? If you send this, how do I know what does this mean? Any guess? We both need to have some contract, right? When, say for example, in a game, let's say when someone says, okay, let's go and play some hide and seek sort of a game. If I give the signal like say cuckoo, cuckoo, this means that I am still not caught, right? That is the contract, that is the agreement. Okay, so there has to be agreement between the person who sends the instruction and the person who receives the instruction. In this case, who is receiving the instruction in this case? Any guesses? Who is receiving the instruction in this case?
Only the seeker.
The microprocessor is receiving the instruction, and the microprocessor usually tells you need to send instructions in this format. That is called as instruction set. Okay, if you just send electrical signals in random order, microprocessor will not understand. You need to send the signals in a way which the microprocessor understands, the electrical signals. Okay, that is what the microprocessor usually does. Okay, so there are a few companies, say, which creates microprocessors. How many of you heard of these companies? Which microprocessor laptop or company laptop you use today? Any guesses?
Sir, I
Intel.
Intel.
All of you are
Intel.
using Intel?
Ryzen,
Yes.
AMD Ryzen.
Great. Who is using Ryzen?
Me.
Okay. Okay. Let me give you a small homework today. Okay.
Sir, even mine is Ryzen.
Great. So all of you, okay, tomorrow when you come back, there is a exercise what you need to do. Okay. You want to take paper, pen, or make a note of it?
Okay, sir.
Yeah. So let's go to your computers. Tell me what is the speed of your processor. First question. Tomorrow you come back, you should tell me what is the speed of your processor. How you
Okay.
figure out, you Google, you do whatever it is. Tomorrow, all of you have to come and tell me what is the speed of your processor, microprocessor. Okay. Second, what bit processor your computer has, whether it is 16-bit, 8-bit, all that information. Okay. Clear? All of you have taken this. The third exercise. Now you should also tell me, say for example, little bit, if it is AMD, okay, if it is Ryzen, okay, which model or which model number it is. Okay.
Sir, model number means like Ryzen 5, Ryzen 7 like that.
Yes. Yes.
Mine is Ryzen 5.
Okay. Tomorrow, not today. Okay. So there are other microprocessor chips, like say NVIDIA is basically a video processor maker, right? There is Samsung, there is lot of Qualcomm, just to name few. There are few others who has done it. The most famous microprocessors in the early ages was from Intel, starting from 8085 and 8086 and 8088, Pentium, Celeron, i3, i5, i7. How many of you heard of some of these names, microprocessor names?
No, sir.
I have, sir.
No, sir.
I've heard, sir.
Sir, I have
Okay.
heard.
Okay. So, can someone take this action item, okay, for tomorrow homework? Okay. Tell me what is some basic differences from these processors. Google, okay, from what we have learned so far, what are some of the basic differences? Okay, at least two differences, two processor differences I wanted to see. Okay. Okay, now let's see. We have seen so far input devices. Okay, CPU. Let's see the output devices. Hey guys, can you hear me?
Yes, sir.
Yes, sir.
Yeah. So far we have seen input devices, CPU, microprocessor. Let's see the output devices. So what
Sir, can you repeat what you said?
Hey, you guys there? Still? Again, I had some glitch. Can you hear me? Hello?
Yes, sir, we can hear you.
Okay. So let's see some of the output devices. So by the definition, what do you think the output devices do?
Sir, which shows the what we say.
So
The result of the input thing we give.
exactly, you are right. So input device converted the physical form interactions into what? Into what did the input devices do? Input devices converted the physical interactions, everything into electrical signals, right?
Yes. For the
And
computer to understand.
exactly. And the CPU processed that electrical signals, right?
Yes.
And what did the CPU give back output? The CPU also, see, CPU can only understand, the computer can only understand electrical signals. It can take electrical signals, process electrical signals, give back electrical signals. Okay. Now, if the computer gives back electrical signals like 101010, can we understand that? Is it easy for us to understand? No, right? We cannot go touch the computer and say, oh, the current is there, current is not there, current is there. If the current is there continuously 3 times, that means A. We cannot do that, right? It's impossible. That's what the output devices do. The output devices understand the electrical signals given by the computer and they show it in the form which we understand. There are various electrical signals. So for display, we have monitor. For printing something on a paper, we have a printer, right? So the electrical signals are converted into the form which the printer understands, and the printer sends the command to the printing head to print the physical paper, right? Similarly for speaker, headphone, projector, all of them. Okay. So how do you summarize this? It converts the binary or electrical signals coming from CPU to human understandable form. Are we clear so far?
Yes, sir.
Okay. So the last thing in that was the storage units or the storage devices. So there are a lot of storage devices, right? So the storage devices can be used to save. Save what? Save the information processed, right?
The data.
So that we don't lose the information, right?
Yes, sir.
So say if you have a file, if you have a video, if you have a music, if you have your homework, all these things, if you don't want to lose it, what you do, you store it in, say, pen drive, memory card, floppy disk, hard disk, all these things, right? So the use of these storage devices is at later point in time, you can use this storage device to retrieve the information back and you can consume it. Okay. Just like how your mom keeps your snacks or your dabba into dabbas so that you can use it for a later purpose. Rice, dal, biscuits, and all that stuff, right? Clear?
Yes, sir.
Okay. Are we ready for some more interesting deep dive? Now we have seen a lot of different components, right? So we have seen CPU, we have seen input devices, we have seen output devices, and we have said there is something called main memory also. That is also kind of a storage device, right? Now let's see what happens here. So the first interaction touch point is the input devices collect the information, give the electrical signals to a controller or a control unit. Okay. And all this information, say for example, is provided through kind of a pipe or kind of a communication mechanism, what we call it as a system bus. Okay. Say for example, let's assume I'm say all of us are trying to communicate each other. How are we communicating? Through internet, right? There is a medium.
Yes, sir.
So within the computer, you can think there is a sort of a communication channel, which we call it as a system bus, through which everyone can communicate. Okay, within inside the computer, there is a microprocessor and there are other devices also. Computer is not only about microprocessor, right? There is input device, there is a output device, there is a memory, there is a hard disk. How do all of them communicate? All of them communicate through a system bus architecture or a system bus, kind of a pipe. So whatever input commands we give, the input devices capture them, convert them into electrical signals. The controllers capture them, dump it into the system bus. Whoever is interested, they can consume this, and the control unit picks this up. If the instruction is to add two numbers, the arithmetic logic unit adds those two numbers, okay, and gives it back to the system bus through the main memory, and the controller of the output device picks it back and displays the result on the monitor. You see from left bottom, it goes all the way through the system bus to the computer processor, main memory, back to controller and output. You see the flow now? A small example I tried to give, okay? Don't worry, these are all just conceptual things. Even if some things are not clear, as we progress, you will get more understanding of it, okay? So far, clear, guys?
Yes, sir.
Yes, sir.
Okay, great. So what have we learned so far?
Sir, we learnt about the parts of the computer, the evolution of the computer, who invented the computer.
We have seen the functional components, input devices, output device, CPU, microprocessor. We have learned something about some small storage devices also, right?
Yes, sir.
Okay. So can we all of us now take some interactive questions so that I can be assured that we are all following this what I'm trying to say. Okay. Let's start
Yes,
with
sir.
who has joined late. Swastik, you joined bit late, right? Swastik, you there?
Yes, sir.
Yeah.
Yes, sir.
When did you join?
Sir, not so late.
Okay. So, what is the whole your whole understanding after going through this 2 units? What's your understanding? Okay, maybe you can take your time. Anyone wants to reflect on what we have learned so far?
So I have one question.
Yep.
In the beginning, you showed us the different types of computers like printers and the normal phones, laptops, and everything. And then you told us about the mechanical computers, like the beginning, like the startings of computers, how they started. I want to ask, like, with the same thing, wouldn't be like the first printer also kind of like a first mechanical computer?
Absolutely, you are absolutely right. So today, almost every electronic digital device acts like a computer. Even a output device or input device acts like a computer, because even printer is a mechanical computer today, but it is also digital. Even printers have a microprocessor. They do have instruction set. They do have operating system within a printer, right? So within, say for example, even a small mouse is a computer, because within mouse there is a small, if you open the mouse, if you have a very old mouse or anything, you should open and see there is a microprocessor chip inside the mouse also. So technically you are absolutely right. Every device, digital device, okay, or mechanical device, right? So today it's a hybrid device. Printer is a hybrid device. It's not a pure mechanical device, right? It takes electricity, it has digital components, it has microprocessor, and it is a hybrid device which is a computer by itself, right? So if you see, how many of you seen printers having display on the top?
Sir, not mine.
Can I show you a big large printer? Let me show you a large printer, okay?
Okay.
So that we all understand. Okay, let's say there is a printer. Okay, here let's say let's take some image. Let's take a bigger one. Yeah, here let's see this one. Okay. Okay. Do you see a keypad here? 1, 2, 3, 4, 5, 6. Can you see my screen, right?
Yes, sir.
Yes, sir.
Is there a keyboard? There is a
Sir,
keypad,
my
right?
printer don't have any numbers like this. Typing.
Yeah, so there are different printers, okay? So your printer might not have numbers, but your printer will have at least one or two buttons where you will touch, you will say color or black and white or something, right?
Yes,
On,
sir.
off, right? That is a keypad. That is the input what you are giving. By pressing mechanically, you are giving input to the printer. There is a computer inside your printer. Okay, there is a CPU inside your printer. Okay, so that takes the command when you press the keypad or keyboard or a button. Okay, so that button sends an electrical signal to that CPU inside the printer, and then the CPU sends other instructions to the output device. Okay, do you see a display unit here? Right, this is the monitor or output device for this computer attached in the printer. What other it's very interesting conversation, right? What other output devices can you see? Say when I press print, what happens? What other output devices you can see in a printer? There is a printing head, that is also an output head. If you send any print signal or a print command, the computer or a CPU inside the printer processes it, sends it to the printer machine, which is a mechanical device, which takes electrical signals and gives the ink to be printed on the paper, right? That is the output device, which we don't see actually, which is there inside, right? On the top, there is a scanner. What type of device is a scanner in the printer?
Sir, it's a output device, no?
No. What does scanner do?
Oh, it scans stuff.
Yes. What does it do?
It process or no, it's input.
Yes, it's input device because you are when you keep a physical document, okay, it reads, it takes the input from the paper, it scans, sends it to the processor, and then it sends it back to your computer to a output device, right? Clear? Any confusions with this? Okay, so let's get back to our discussion where we were actually. So any questions? Arnab, Devdutt, Neil. Okay, so now do we have some basic understanding of what a computer, what components, how does it work, how does it process? Do we have some basic understanding? Why don't we turn on the video? Maybe that would be easy, right? So that we can see. Hello. Hey, Devdutt, you have been active all the time. Good, good, very good.
Thank
Hey,
you.
Neil. Yeah, so how was the first two units? Did you guys follow? Was it easy, tough, confusing?
No, sir, it was understanding.
How about Neil? Did you follow the concepts?
Yes, sir.
Okay. Any clarifications? Okay.
No
What is
doubts.
that new thing you learned today? What is that one thing new you learned today?
Sir, the evolution of the computers.
Great, great. Anything else?
The binary code.
Yeah, so we will be see, it's important not just to jump into coding, right? So our foundations has to be very strong. Okay, only then we will be able to understand what is happening inside the computer, right? If there is something which is going wrong, you have to troubleshoot within the computer, right? So you have to know what is happening inside. how it happens and all that stuff. Only then you'll be able to really debug. Otherwise, you'll be like stuck. Maybe you can write some program by just Googling or just by copy pasting. But if there are things which are going wrong, how would you troubleshoot? How do you know what's going on, right? So that's why it's very important to understand the whole basics and the foundations of it, right? Now we have seen that. Okay, should we start the next topic right away? How many of you are interested to start the next topic? So far,
Sir, I'm okay with anything.
So far, what have we seen? We have seen about evolution, hardware. Mostly, what we have seen is about the computer's definition, evolution, generation, and some hardware basics. What computer input devices are, output devices are, and all that stuff, right? So the next topic is to start with software. Okay. So let's start the software part, which is very interesting. So we are not going to start programming tomorrow. So tomorrow, let's start with the software concepts. Okay. Unit 2. Okay. See, I thought maybe we will have a lot of questions, and that's why I've kept a little bit time in between. But I would encourage you guys to do ask a lot of questions. Okay, even if it is basics, it would be kind of a memory recalling all the stuff what we knew earlier. Okay.
Sir, I have one